This is a lesson on how to find the area under the curve using a trapezoid rule. So the area under a curve above the x-axis on a given interval can be approximated by dividing the region into polygons. Thus far we have used rectangles. Today we're going to start using trapezoids. Trapezoids generally give a better approximation of the area because they tend to include more of the region that is sometimes missed by rectangles. So take a look. If we look at these two curves and we draw some rectangles, oop, that one's kind of bad. You can see we're missing a lot of the area, and we have a lot of extra on that one side. But if we took this one, and instead of drawing rectangles, we drew trapezoids, so let's divide it up into 4. That works out pretty well. 1, 2, 3, 4. There's going to be a lot less waste. Not the best drawing, but you get the picture. I'll probably slide this over a little bit. There, now it fits better. So if we took this curve and we divided it into, let's say, 1, 2, let's make a couple trapezoids. So let's draw one here. It's kind of nice because it's a little even. One here, and then we did one here. And then we did one here. And then this one will have one like here. And then one that comes up like this. And we'll do one more. Obviously it would be ideal if the lines came out straight, but we have 1, 2, 3, 4, 5, 6 trapezoids. They all have something in common. Well, almost all of them. They all start they're all going to share a base. The first trapezoid is actually going to share this base. Now the second trapezoid, it will share a base here and here. So let's just consider this first trapezoid. This blue guy right here. It has an area of 1/2 height times the two bases. Because what we're really doing is we're averaging together the two bases times the height. So when we say the bases, we're really talking about this length and this length. So again, the bases are 1, 2. So we can see that this base height is really f of 0. And then that second base height will be f of 1. And we want to average those and multiply it times the height. Now when we say the height, we really don't mean the height. We're talking about how wide is this interval. Well, this interval has, obviously here it's 1, but it's just going to be whatever the width of our interval is. Now if we did this for every single rectangle, 1, 2, 3, 4, 5, 6 rectangles, the next one would be f of 1 plus f of 2, and we'd start repeating things. Because, let's make this guy red. This red guy, he's going to be f of 1 plus f of 2, those are our two bases, divided by 2, times the height, which is in this situation just 1. And then as we start to add these up, we see we're adding up, here we're adding up f of 1, 2 times. And the next one is going to start f of 2 and then f of 3. So is there a way we can compress all of these calculations so we're not repeating ourselves over and over? Alright, so if we put all these areas together, what's going to happen is we end up with 1/2 height, because they all got 1/2 height. And then the first rectangle was f of 0, trapezoid, plus f of 1. And then the next rectangle was f of 1 plus f of 2. And then the next rectangle would be there it goes. F of 3 plus f of 4. And we could go on like this forever. Whoops. No, we can't because we missed someone. That was f, sorry, of 2 plus f of 3. And we could go on like this forever. And we really could go on like this forever. And what we would end up doing is saying, all right, well, what we've got here is 1/2 height. We have 1 of the first base. But then after that, we've got 2 of every base in the middle. I mean, like, we could go on like this forever. But we're not going to, because that would take forever. 3, dot, 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 dot. And then whatever the last base is, we only have 1 of that base. So notice that the first base is used once. And then the same rule is for the last base. All of the other bases are going to be used twice because all the other bases are shared, except for the first one and the last one. Okay. Also, b minus a over n is the height, otherwise known as if I take the first base minus the second base, that's going to give me, right here, that's going to give me this width of each little rectangle. So here we go. Here is our area under the curve using n trapezoids. Now, n trapezoids, this is just the number of trapezoids. All right. So we've got our formula, and now we are going to approximate the area under the curve using 6 trapezoids between 0 and 3. Now, 0 is going to be our A value. 3 is going to be our B value. Now, I just want to point out that this is another way to write this problem. This is called an integral symbol, and very shortly we will start using this symbol to find the area under a curve. So here's just some examples of some trapezoids that that ways that we could do this. Then obviously the more trapezoids we use, the more accurate it's going to become. Okay, so I graphed f of x on my calculator, and I can see that, just ignore all this stuff, we've got a parabola. It's got an intercept over here and then another one over here, and it looks like it's a little bit past 4. And we're looking between 0 and 1, 2, 3. So we are looking to approximate the area under this under these two boundaries using 6 trapezoids. Now 6 is our n value. If we are using 6 trapezoids and we have a width of 3, that tells me that we are going to have width of 6. Let's see if I can do a trick here. Oh yeah. Okay, so what I need to do is find all the y values between 0 and 3 every 0.5. So what I'm going to do is I'm going to go on my calculator and I'm going to go to my table. So you can see what I've done here is I've set up my calculator table. I went to second window and I set up my table so that I was starting at 0 and moving every 0.5, because if I want to fit 6 trapezoids between 0 and 3, I need to have a trapezoid every half a unit. And then when I went to my table, you can see I have all these lovely y values here. And so I've got f of 0, f of 0.5, f of 1, and so on and so forth, nicely set up using by changing my table set to the width, which was found by, again, B, ooh, that is really big. B minus A over N. So in this case, again, it was 3 minus 0 over 6 gave me that 0.5. Alright, so again, that's how I got this value. Alright, so now what I need to do is I need to set up my calculation. Let me get rid of some of this stuff. Oh, that was scary. Oh, get rid of that. Ah. Okay, so never mind. We'll leave this stuff because that got scary. What we want to do is we're going to say, all right, 1/2 our height is just 1/2. And now we need to do f of 0, which is 1, plus 2 of all of these guys. All the ones in the middle. So now I'm gonna go to my calculator again. I'm just gonna type in 1, 2 times, and now 1.875 plus 2 times 2.5, and then I'm gonna keep doing that, all of them until I get down to the lonely little 2.5 that's right here, and that's just gonna be added once. When I add all of that fabulous stuff together, I get 7.3, sorry, not 3, 7.43. Here, I'll show you. Okay, so now we can see that I added it all up on my calculator. Looks very beautiful. And there is the area under my piece of a parabola between 0 and 3 using 6 trapezoids. So let's take a look at number 2. Yay, lots of space. So it says use the trapezoid rule to approximate the area under the curve e to the x between 0 and 1. Compare the results for n equals 4 and n equals 8. So the first thing I want to do is grab my calculator and type in e to the x. And I also want to figure out how wide my cute little trapezoids are going to be. So if I'm going from 0 to 1, I'm going to say 1 minus 0 divided by 4 is going to be widths of 0.25. So the first thing I'm going to do after I type in e to the x, and we all know that e to the x is a growth function, and it looks like this, whoop, is I'm going to go to my table set, second table. I'm going to start at 0, and I'm going to move by 0.25. I'm going to grab my table. Alright, so here are my table values for e to the x, and I really only need these first few. Remember, I'm going to use the first one once, I'm going to use the last one once, but these 3 in the middle, I'm going to use twice. And I might want to take a look on my calculator at that one at 0.5 because it looks like it goes on forever, and it does actually, a lot of them do, but, you know, that's life. It's just an approximation. So, let's calculate. Okay, so now you can see here's our area using 4 trapezoids. So if we want to use 8 trapezoids, then now we have to do 1 minus 0 divided by 8 to get 8 trapezoids. And we're not going to do that because that's just a ridiculous amount of typing, so you can cross that guy off. Alright, and that completes our lesson on the trapezoid rule. Homework are pages 8 and 9, and there's answers all the way at the bottom of page 9. Remember, those little integrals, like when you see it say from 0 to 1, those are just your boundaries, and it will tell you how many trapezoids to use.